Recording it. Hi everyone, welcome to the data analysis week 3 or week 4 lecture on training. So I'm just going to quickly go over some things. So this week you'll be starting to work on your portfolio projects. I know I'm pulling the date a bit early because I will not be available for the next 3 sessions. What I will do is I will try and record the sessions in advance and upload them every Thursday night. So you can see it, follow it, and then practice it. And then I will share this link soon. We have 1, 2, 3, 4, 5 data sets. You guys can pick whatever data you want and start doing analysis. So every time I teach you something in one of our lectures or training sessions, you can apply it to these data sets and see what happens. What I will say is I'm going to lock this, but you can make a duplicate of this one. So you can go click on file, make a copy. And then once you make a copy of it, you can start working on your own personal Google Drive and do the analysis. But yeah, one thing I know some people were joining the calls, clicking on Hangout. When you join the call, you will always be there. And to leave the call, just click on the disconnect button that's at the bottom over here. And in your mobile phone, it will be the same thing. And then I wanna say this. Good job to everyone that introduced themselves, because if you introduce yourselves, we know what you're looking towards, what experience you have, and how to interact with you. If you don't introduce yourself, it's almost like you're not interested in this group and you don't want to partake in learning and everything. And it'll be very difficult when you're applying for jobs, because when you're applying for jobs, the first thing you do is you have to introduce yourselves to everyone there, so they know how to interact with you, how to work with you, and then know more about you. Right now, I know some people in this. There are how many? 1, 2, 3, 4 introductions here. So out of 8 people here, there are only 50% of the members introduced themselves. The other 50% did not introduce themselves. I hope that changes soon. And the same thing, I with the feedback, whenever something happens, the way I teach or anything, if you give me a feedback instantly, then I'll try and improve it for the next session. If you don't give me any feedback, that means I'll just keep on doing the same way I'm doing. For example, 2 weeks ago, I know FN Bola mentioned something about me going too quickly. So I'm slowing down, going through everything in detail, and trying to include as many examples as possible. And I'll continue doing it that way till someone else tells me that I'm going too slow. So no feedback means I'll stay the same. And if you give me feedback, I'll try and change the way I'm teaching. So yeah, there's this thing called tasks, which I will try and get it running sometime soon, which is hopefully by this weekend. And that's when you'll start working on your own portfolio projects. And I'll start giving you question and answers here. So rather than me giving you homework, it will be training tasks that will just pop up once a week or twice a week over here. So yeah, just remember, and every time I do something, I'll always post in an announcement channel. And if you have any questions, please continue to do as you're doing here. I know Amos is the only one that's been asking me questions, but I hope everyone can do the same here. All right, let's get back to the training session. The first thing, we're trying to continue our statistical foundation from last week. So the agenda for this one will be statistical foundation recap, and then continue working on it. And then I'll do some example portfolio/project work, so you can try and copy it for the rest of them. Quick recap here. What we went through last week was properties of data. Oops, someone's running. Almost. Properties of data. And then in properties of data, we have the scale, ratio scale, interval scale, ordinal scale, and nominal scale. So when you're going towards the left, oh, if you're going towards the left, you will see numerical data. And if you're going towards the right, you'll be seeing nominal data. What that means, not nominal, categorical data. And if you want to learn more about this or get a reminder, go back to lecture 1 or lecture 2. So yeah, and then another quick recap, whenever you're doing an analysis, you would never do your analysis on the population data, because you can never ever completely collect the entire data. So you'll always be working on a sample. So always keep in mind, because you're working on a sample, the data you collect will always be a bit biased. And you need to understand what kind of bias that is. Generally, when you collect data online, you don't know what kind of bias it is. But if it's a first-hand data and you're collecting it, let's say the period like in December, then if you're collecting retail data on in December, that people buy a lot more products than normal. So that's kind of influenced on what kind of things you're doing. And if people are buying something with a lot of sale on, then again, they're only buying it because it's December, which is Christmas period. And if you do the same sale in the middle of the month or middle of the year, they might not buy it. So always keep that in mind. Where are you collecting data? What kind of bias is it generating? Because you can never ever gather the population data. It's just a recap here again. Carrying on, we spoke about descriptive statistics, which is nothing but you're trying to understand what's happening right now based on the incoming data. You're just giving it very descriptive values. So it's the first kind of analysis you do. It's applied to large volume of data. And keep in mind, description and interpretation are two different steps. So description is saying, oh, the mean of the data is X. The standard deviation of data is B or Y. And then you explain that, oh, the mean is X compared to the mean of something else, which is Z. And then you like the standard deviation for this is Y, and the standard deviation for something else can be like B. And you try and say which one is higher, which one is smaller, and then compare them. Always keep this in your mind. You always give the value first and then the explanation. Because I was quickly going over the session you had with Ola last Saturday, and I know a lot of people just put the graphs on and be like, yeah, this is the data. I know only a very few people. I think Bola is the only one that had a full report written for it. So a good job for that, Bola. But everyone else, I expect you to be explaining it as you go along. Because end of the day, if you have a very high level executive, they won't have enough time to look at the data and try and understand what's going on. They want to read one or two lines, be like, yes, that's what's happening. I understand that. The data is showing the same thing. And that's it. They don't have more time to do anything. So keep that in mind. Explanation is vital, and succinct or very small explanation is even more important when you're writing it down. So these are all the things that we learned last week. Again, this is very, very basic level statistics. It's important range, mode, median, mean, quartile, standard deviation, variance, and everything else. So if you break them down into different sections, these two sections, the one on the left-hand side is the measure of central tendency. That means the average data. So whenever you go to, let's say, when you're trying to buy a house in a new area, you'll be like, oh, what's the average price of the house over here, guys? And then they'll say they won't get a list of every single house price they know, take an average of it. No, they will tell you the most common house price that's been sold. So that will be a central tendency that's mode over there. And the same way when you go to, can you try and find the height of a, no, the height of a student in a class, what's the average height? You might get the median. You'll be like, oh, the median height of a person is 1.3 meters or something. The same idea. And then range, interquartile range, variance, standard deviations, and quartiles are measure of dispersion. So central tendency is the average right in the middle. And then dispersion is the spread of data across it. And then all these variables or parameters are the ways you describe them, saying, oh, you went up, yeah, how far apart they are, etc. Again, these are not exhaustive lists. You can add more and more things to these. But what I've shown you here are the basics and important principles that you need to know. So we're going back to this graph, which is the distribution graph. I'll explain what a distribution graph means soon, or in later on during the training. But you need to see you have the mean in the middle, and then you have the standard deviation minus and plus on both sides, showing you the dispersion. So mean is a central tendency, and standard deviation on either side of the dispersions. By the way, there is a mathematical proof to explain. I know someone asked me this, is one or two standard deviations. One standard deviation plus or minus from the mean is 70%, two standard deviation is 95%, etc. I was trying to look into this over the week because I did the proof when I was in university, 8 years ago, but I completely forgot it. But there is a mathematical proof to explain why one standard deviation is 68, 69%, two standard deviations 95%, and three standard deviations is 99%. It's not all the data, but it's 99% of the data. Everything also that's beyond this is generally an outlier or extreme data. So yeah, that's basically very quick recap. So I'm just going to go over this again. Properties of data. We spent through ratio scale, interval data, ordinal, and nominal. Everything that I explained in the last week is based on the ratio scale. When I say ratio scale, it's numerical values. And then let's do a quick analysis on what the can ignore that. We can do a quick analysis on what nominal data means. Does anyone explain or take a shot of what a nominal data means? I'll give you 5 seconds to think about it. What is a nominal data? What do I mean by that? I guess people are still unsure about what it means. Nominal data is just nothing but a categorical data that can't be represented with a numerical value or on a scale. If I say America, or sorry, North America, and I say Africa, they're two different continents. You can't compare them unless you look at different attributes, like saying the area of it or the population of it or what kind of land it has, because you can't compare it. They're categories. So nominal data is just categorical data. How do you analyze? So till now we've done ratio scale analysis, but how would you go about doing analysis on the nominal data or categorical data? So the first thing you do is you do a frequency analysis. So over here is a table that I've found online, which tells you the outcome of children's heart surgery in the UK and Irish hospitals between 2012 and 2015 in terms of survival after 30 days after surgery. So the one thing you'll be given are the number of babies that go to the surgery and the number of surviving or the number of babies that survived after the surgery, 30 days after the surgery, basically. Let's do some analysis on that one. Oh, if I can get that up. So here we go. So it's the same data I've given it there. So can everyone see this one?
Yes, yes, yes.
Yeah.
Yes, we can.
Thank you. Yeah. So yeah, over here you have the hospital, you have the column headers over here. Hospital, number of babies with the going for the heart surgery, babies that survive after 30 days, and the babies that are dying after 30 days, etc. Let's try and fill some blanks. So number of babies are 418, and then surviving after 30 days is a 413. So what does that mean? How many babies died?
5.
That's correct, yeah. You do first one minus the second one. Total, take away the babies that survived. And then if you fill up, you get this one. All right, the next one is trying to fill this one. Percentage of babies that are surviving. How do you do that one? You do this divided by the total number of babies, the surviving babies divided by total number of babies, and times it by 100. Actually, I'm not doing it times it, but I'm just going to do that one. Leave it in the decimal value. And after you do that, you can right click and you can click on format. Oh, all right, there is no formatting here. I've been working on something else. Sorry about that. So yeah, what you can do is in the formula, I don't know if you guys remember this. You remember the round formula? You're rounding it to a certain number of decimals. You divide rounding that to, let's say, 2 decimals, and you're timesing this by 100 to get the percentage. No, that's 4. And then you do the same thing for every one of them. And then you can do the same thing again. Round the percentage of babies dying. You can 5 babies out of 418 babies are dying. You want to round that to four values and then times it by 100. There you go. That's basically filling in a table. Now, let's think about this one. if and when we're doing analysis in the ratio scale, we can do things like taking a mean, taking an average, taking a mode, taking a median, everything else. But can you do the same with this categorical data? You can't. The only thing you can do is taking the mode of the data. Do you remember this from last week when we were talking about this, guys? I'll take it you guys
Yes.
remember. Yes. What is meant by a mode? It's the most frequent value. So in this kind of data set, what would a mode be? Mode is the values with the highest samples. So over here, number of babies with the heart surgeries. If you look at this one, what we can do is we can sort this. All right, let's create filters for, oh, wrong button. Let's create filters for everything and then click on this. And then we can sort A to Z, smallest to biggest, or sort Z to A, biggest to smallest. And I can see the value. London Great Ormond Street has the highest number of people that are visiting it. So, okay, that's the most common hospital. And then the one in the Harley Street in London is the least common hospital. So that's how you can do the mode or you can do the analysis of it. So remember, when you're doing it for the ratio scale data, analysis is average, saying what is the average data, or you can look at mode and median, but most of the time you look at the mean of the data. But in categorical or nominal data, you look at the mode, saying what's the most common one. And the same way, I know that London Great Ormond Street has the highest number of people that are going there. Do they also have the highest number of people with the babies? That sounds really bad, but the baby's surviving after 30 days. And the answer is yes. If you still order it that way, you still get the highest to lowest. What about if I do dying after 30 days and highest to lowest? I'll get Birmingham as the one. Anyway, is this safe to say that Birmingham is the worst hospital to go to because it has the most number of deaths? Do you think that's a valid thing to say? It's a yes or a no answer. And in the same manner, is it valid to say that London, Great Ormond Street is the best hospital to go to because that has the most surviving or most surviving babies? It's a good thing. Is that the right thing to say?
No,
Thank you very much, Ayodeji. Yes, it's no. Do you want to try and explain why we shouldn't do that?
the reason is we should look at the percentage rather. All right, the percentage of dying and the percentage of surviving. That's what we should look at.
That's very good. Yeah, that's very clear. And the reason being, let's say I have nine. I don't know if you guys remember this, but from the very first week when we are doing the analysis, we tried to look at data analysis, cloud computing, and etc. How many people enrolled the seminar for those courses, and how many people actually joined. If you find out that the majority of the people that enrolled for the data analysis class is the highest, and in the same way, the number of people that joined the data analysis class is the highest. So data analysis is the best. Yes and no. We can't say that. All we have to look is we have to try and make all the samples equal, or we can take a percentage of it and look at that. So you sort this from highest to lowest, and you find out London, Brampton, the one with the fifth highest number of babies or attendees, have the highest surviving rate and the least um, fatality rate or mortality rate. And Glasgow, the one in Scotland, has the lowest surviving rate with the highest mortality rate. So that's how you compare them. So most of the data is look at the raw value and then you compare the percentage of it rather than looking at the actual values over there. Okay, now the next question here is how do we go about presenting this data? Because till now, until last week, I've been explaining about how to analyze the data using the basic statistical principles. But now let's go one step ahead. How do we go about presenting the data? I know two people in this group tried to present the data in the course last week. So do you know? And I think you guys know who you are. Do you want to try and explain or tell me what those are? Okay, whenever I hear the silence, it feels like no one understands my question. Someone points.
Correct.
Oh, wait, that means you don't understand my question and my point. The question is, what kind of graphs did you use to, what kind of graphs or data visualization techniques can you use here? There you go. Ooh, I just lost the entire thing that I've written there.
You can use pie chart.
That's correct. Pie chart is one of them. And the other one is bar graphs. I believe FA is the one that did the bar graphs. Nobody did pie charts, but yeah, bar graphs. So how do you do bar graphs? I think Google Sheets are smart enough, so you can select this entire thing and you can go to Insert Chart. And there you go. You get the simplest one, bar graph. With the bar graph, it's very clear to see. Let's do this one, A to Z. So it's very easy to see which hospital has the highest number of patients or attending because it's the one with the tallest graph. London. That's in Great Ormond Street. In the same way, you can change the chart style, setup. You can change the column chart to a pie chart. Any of these three pie charts are fine. In the same way, the one with the biggest share is London Great Ormond Street. You can see the percentage as well, 14%. And then the second highest is, I think it's Birmingham with the one with 11%. So yeah, those are the two graphs that you can use to visualize it. Yeah, that's basically it. The bar charts and pie graphs, pie charts. Does anyone have any questions surrounding that? Live demo. Yeah, there we go. A bar chart showing how you could. Oh, by the way, the bar chart doesn't have to be the number of babies that are attending there. You can also show how to let's do. I'll show you how to select different columns as well. So you click on Insert Chart, and then you can go to Select Data Range, and then you select A to A14 being your columns or the x-axis data, and you can select the y-axis over here, which we are looking at the percentage of people that are surviving. So it's E to E114. So there you go, you can see it right there. Can you see the difference or the difference over there clearly? You can't, so you can try and customize your vertical axes. So you can have your minimum value to be 80% and your maximum value to be 100%. Okay, that's 0.8 and 1. Again, percentage is 1, value of 1 is 100%. That's why you do 0.8 is 1. Even that's still very difficult to say. You can change them to 0.95. Now, can you see the one with the highest surviving rate or mortality rate? It's London, Brampton, followed by London, Great Ormond. And the lowest ones are Glasgow and London, Evelina. Those are the two values. In the same way, you can go to setup, change it to a pie chart. You can have any of these pie charts. They're all the same things. And then you can say what color you want. And if you want, let's say you want to move Glasgow for being the worst away from it, you can do 25%. You can pull it outwards. That's basically it. You can give it border colors. Just play around with these things to try and make your chart prettier. Again, keep in mind, whenever you're doing this, you always have to explain the data. So if I go there, Glasgow is that one, then London, Great Osmond, or do the same thing over here. So the two data that I picked over here, let's move this data set over here, and I can write description, pie chart. The graph clearly shows that it doesn't clearly show that. I'm going to change that to something else. I'm going to change it to bar chart. Where is this column? Bar chart, and then I can do that one. Bar chart. The graph clearly shows that London, great. Let me get the spelling right as well. Ormond Street has the highest mortality rate. While, okay, let's write this right as well. With no, it's London Brampton. What am I saying? London Brampton, yeah, not Great Ormond. Brampton. Brampton has the highest mortality rate with 99.17%, while Glasgow has the lowest or the highest fatality rate with what is it? What does it say? With 3.55%. 3.55%. See, now if I'm doing these analysis, and because I wrote this one line explaining the entire thing, it makes your life so much easier because rather than trying to point your fingers at this one saying, oh, this one has the Glasgow's lowest and London Brampton has the highest, you can just read that and be like, oh, that makes sense, etc. Is everyone following that?
Yes.
Yes. Thank you. So just adding these values, these explanations just makes it so much better. And you can use whatever you want. You can use pie charts to explain how many people went there, or you can use bar charts to explain it. Just making sure the scales are easy to understand and see and compare. So yeah, that's basically what you do for nominal data. You look at the frequencies of it and you put them in a bar chart or a pie chart. There's not nothing else. Well, we can do more with it, but it's in conjunction. So you take a categorical data or nominal data, you break your entire data into nominal categories, and then compare each and every one of them. So to give you an example, let's go back to this one again, and I'll go to good fitness. So over here we have how many? We have one, two, three sets of products: TM195, TM498, and TM798. And if you want to compare, and those are three nominal datas. So you can compare those two, or you can break your data into those three columns or three data sets and compare them. So how do you do that? You select all of this. Actually, let's choose something easier. Okay, I'll leave the hard one for you for as homework. So rather than doing the product, let's do gender. There are only two genders, male and female. So if we do A to Z, you have how many? 76 female, and then you have 104 male. So you can write down here male, female, count. And how do you do count values? You do count this entire data if it's a male. Of course, I always spell this wrong, don't I? No, what did I do wrong? Because the function is not count, it's count if range. That's the range, and the criteria is saying it's male. Can you do this for me. There we go, 104. And I can do the same thing. Equals count if this entire range and it being female. All right, let's look at the fitness average. Okay, fitness average equals count ifs conditional and cross count. No, that's not how you do it. Equals average if criteria range is this entire value. Oh, by the way, I'm introducing a new function over here. It's called average if. What you do is you go to the criteria range, you say what the criterion is, it equals to mil, and then you can go to same row and select the data because we're looking at the average fitness. Okay, let's do something average income. That's even better. So you can choose the same range for the average income. There. And then now, if the first one is female, then it won't be accepted in there because it will be filtered out. But if you scroll down all the way here to the first male, because it's male, it will be accepted, and this one will be added in the range. So that's how you use the average if. And then this one equal to the same thing, average if. Keep in mind, this is very important when you're doing categorical analysis down the line, guys. You can select the entire C column saying it's female, and then you can pick the data from the income there. Close it, and there you go. So income average. And then let's see if there is a way to do it. So there you go. You can decrease the decimal points right there. That makes no sense. Let's decrease it even more. There we go. More formats, numbers, or currencies, currency rounded. There we go. That's what we select. Can you see it? Male has a higher income range than a female. That's basically it. Does anyone want to try and take a shot at saying how to do the fitness average or the miles traveled average, guys? Who wants to give it a try and tell me what the formula is? You can type it down in the chat section, that's fine. And to make it clearer, I'll write down the formula that I used in this area. There you go. I'll give it a minute for you guys to type it down because I know it's going to be extremely long. Rather than saying that, we can always say it's the entire C column, the entire K2, not the entire H column there. There you go. That's the formula for the top one. No one's typing. Does my question make sense? Oh, nice. Thank you. Average of gender E. Okay, let's copy the entire thing there. Thank you, FA, for writing this down. You must have been writing it very quickly.
Yeah, that's average if gender. That was the whole of the gender column.
Yeah.
I don't know what column that was.
C.
Yeah. And then where the mouse is.
Yep. And
Is
then
it I1?
that's
Yeah.
right. I use the mouse. Very good. Nicely
So,
done. Yeah, you got it
Yeah.
right.
Yeah.
I'm just gonna quickly do that. That's the one, and then you do
Yeah, and then you do the
height.
mount. Yeah.
It's not letting me do it as I wanted to do it, so I'm just going to select that. There you go. You got it absolutely right. And you do the same thing here, equals average if, criteria range, which is C. And then if that equals to female, and then this one. And in the same way, guys, you can do, I'm doing the average over here, you can do standard deviation. So equals standard dev if that doesn't do it for us. If right. I don't remember this by heart, but same idea. I will write the equation down towards the end of the call, which basically says what formula you have to use over here for standard deviation based on a selected column. I was going to go with this at the end anyway, so we'll do that then. So going back to representation. So that's what you do, and then the way you do analysis for nominal data is by looking at its other attributes. For example, in this example we've done just now, we know for female, for every female, we looked at the income and the miles. And the same for every male, we looked at the income and the miles. So the nominal data being gender. We look at the ratio data there, and then compare it. So that's what you do. Before I do that, I just explained this over here. So description being males have a higher income than female by almost 7,000, by almost 7,000. And they also use the fitness machine on average 20 miles more than female. There you go. So rather than looking at this data, people can read this and be like, oh, they understand what exactly you're trying to show there. Always keep in mind that you need to have descriptions every time you do any analysis. Unless you're doing visualization with Tableau or Power BI, that's the only exception because that's live data visualization, though you don't need descriptions. But if you're writing a report or anything, you definitely need them. Anyway, I went through nominal and ratio scale. Let's talk about interval data and ordinal scale. Again, the same thing here. You do frequencies. So to double confirm or to make sure everyone remembers what interval data and ordinal data are, interval data is a range saying, oh, anyone between the ages of 25 and 30. Or you can say something like anyone between the ages of 13 and 19. But ordinal scale is something that can be arranged in a scale. For example, ages. So just now I said 13 to 19, which is basically teenagers in ordinal scale. Anyone below that is kids. Anyone above that is young adults, middle-aged adults, old people, etc. That's why these two can be combined and analyzed in a very similar manner, which is again frequency. So how do we convert the data that we're given into frequency tables? For example, if you're doing a survey, yeah, it makes sense. People just tick whatever data you want them to select. But if you have a ratio data saying 1 to 13, how do you do them? So you can create a table 1, 2, 3, 4, 5, 6, and then say how many times it has happened. Yeah, everything happened once. But again, if you do a table like 1 to 5, 6 to 10, 11 to 13, you can try and find the frequency there. 5, 5, 3. And there you go. You can present your interval data in the same manner as a bar chart, which is 1 to 5, 6 to 10, 11 to 13. But again, this is a different name. Instead of calling this a bar chart, you can call it an histogram. A bar chart is where the X label is a categorical data. It's not or nominal data, not categorical. Nominal data, yes. And then a histogram is when the data below this is generally an interval data. So 1 goes over here, 5 goes there, 6 goes here. So 5 is between these two values. And anything from 5 to 10 will be there. From 10 to 13 will be here. It's a combined one. That's what it is. And now I've shown you how a histogram looks like. Let's talk about normal distribution. This is something that you all have to get your head around. It is an ideal distribution, which is symmetrical around the mean of the population. So the keywords being mean and population. So if you collect the entire data of a population in the world and you plot them in this interval data scale, something like this, which you selected smartly, you'll always get something like this. It will be a normal distribution. If you draw a straight line in the middle, it will be almost symmetrical. That's what it means. That's an ideal scenario, but you normally don't get that because of the sample issues. So whenever you collect a sample, you can get different skews. So if the data is, I need to say this, if it's going to the left like this, in the first one, you can call it positively skewed. And if it's going to the right, you can call it negatively skewed. So skewness is just a value saying it's a positive skew or a negative skew, saying wherever it lies in the data. And then the other one for a distribution you can look at is kurtosis. Kurtosis is basically saying how sharp it is, how close or far away it is. Can anyone tell me what is the parameter or attribute or factor that defines the kurtosis? So what is the kurtosis measuring? What is kurtosis measuring in this distribution graph?
The standard deviation.
Very good, yes. It is measuring the standard deviation or the dispersion of it. So the higher the dispersion, the higher the kurtosis value, so it's more spread out. And then the lower the standard deviation, the closer it is to each other. That's exactly right. It's measuring the dispersion of it. Thank you very much, Bola. All right, next one is a box plots, or also known as box and whisker plots. So we went through this last week when we were doing the range, interquartile range and quartiles. And then we did the quartiles at 0, 25%, 50%, 75%, and 100%. And the reason being, before we do that, that's for doing the box plots. And then have you guys come across data cleaning and outliers in the data? What is an outlier? Emmanuel tried to explain this last week. So do you want to try this chance again, Emmanuel? If you don't respond, I'll just take it that you're away from your keyboard. Oh, you're here. Nice. Carry on.
So yeah, when you take random samples of data, yeah, outliers are actually the data that are not how will I put it? They're not close to they're far away, they're so dispersed from um the actuals. Let me just put it that way. For instance, if you have, like, let's say 1, 2, 1, 2, then you now have 5.
Yeah.
The 5 there is the outlier because you can see it's far apart from the other. So that's the way I can explain it.
Yeah.
If you take random samples,
go on.
If you take random samples, so for instance here, the outlier, if you ask me what the outliers here are, I would say 5 and 7.
Very good.
It is a 4.
Easy.
4. Okay, yeah, I'll say it's 7 now that you've changed it. It's 7 because you can see it's so dispersed from.
That's right.
Yeah, so that's the way I can explain it. Thank you.
So it's an extreme data that you can't explain it's an extreme data that doesn't follow the normal trend. Or the other way of saying it is 3 standard deviations away from the mean of the dataset. Or the other way of saying it is using this formula over here, which is using the interquartile range, which is 75% take away 25%. We call it the IQR, and we multiply by 1.5. And what you do is you get the upper limit by doing the upper quartile, which is 75%, plus 1.5 times IQR. And you get a value. Over here is 6.75. And then any value that's greater than 6.75 is an outlier. And the same way you do it for the lower quartile, which is 1.5, take away 1.5 times the interquartile range. And you get minus 2.25. There is no data that's smaller than minus 2.25. So there is no lower outlier, but there is one upper outlier because of the 6.75 rate issue. So anyway, let's just reverse them all around, go from 100 to 0, and you do the box plot in this manner. So 7 is an outlier, so you put a circle there. The next 100% value will be 5. So you draw a scale at 5. And then your 75% is between 5 and 3. So, well, it should actually be at 4, but because they're getting rid of 7 as an outlier, everything gets shifted down, and it should be at 3. But again, I don't know why Python is doing it this way. It says your upper quartile is 3.5, lower quartile is 1.75, and then your sample is 0. Lowest value is 0. That's a box plot. So let's go with this one. What a box plot shows you is the spread of the data. So keep in mind each and every segment over here from 0 to 1.75, it covers 25% of the data. In the same way, from 1.75 to 2.5, it covers 25% of the data. Each section covers 25% of the data. So you can see that to see how your population is distributed. So over here, that's your random distribution of the samples. It's all over the place like this. But then you can see, oh, there are some outliers here, and then the 25% of data is over here. And there's a very strong closeness near the middle 50%, because they're very close to each other compared to this 25% range. And then that's how you describe them. It makes more sense when you're starting to describe multiple box plots together and to show what it means. So what we've done now is we've completed the descriptive analysis with univariate data. Do you guys know what a univariate data means? It's a single value, single parameter or attribute that you're measuring, and you're comparing that one thing alone. So everything that we've learned with all the plots, with all the graphs and everything, you're just analyzing single variate data. So if I go here, all these factors, they look at a single data and analyze it. Box plot is for a single area. Normal distributions and everything is a single data analysis or single variable analysis. Oops. So that's what we've completed now. And then next week, we'll be doing analysis with bivariate data. When I say bivariate, you're comparing 2 data sets with each other. Can anyone give me what it means by a bivariate? Give me an example of a bivariate data analysis. You guys have done this in your presentation or report last week. So does anyone want to give me an example?
Is it comparing 2 stocks like Facebook and Apple?
Yeah. When you're comparing them, what did you plot? Did anyone plot a scatter graph? So in the x-axis, it shows Facebook. The y-axis shows you Apple. Did anyone do that? I take it no one did, because the idea, all I was just trying to find out how much you know, and then to try and get a general idea on how much you need to learn and what needs to be taught. So people with experience would have tried to do these kind of analysis and then try to compare them to see, is there any correlation between those two things or not? Anyway, that's not an issue. So yeah, that's what it is. And then I'm going to repeat this again for the next 3 weeks. I'm going to India for an urgent sensitive matter. So what I will do is I will record all my sessions and upload them once a week, and you can read it and follow along it. It will generally be between 1 hour and 1 hour 30 minutes, where I will spend the first 45 to 1 hour explaining what we're doing, and the last 30 minutes going over examples. And then we'll go back here. So what I'm doing now is I'm uploading all these kinds of data. When I say all these kinds of data, I'm uploading data sets for you all to practice doing data analysis. So yeah, there are some of them that you need to clean the data. For example, you need to clean the data for New York housing data and the grocery data. There's a lot of random and excess information. So you just need to pick what you want to analyze and go from there. And I will try and add more data sets here as we go along. Keep in mind, you can always download this. Where is it? Download it into whatever format you want to do your analysis at home. Or you can make a copy and do it on Google Sheets. Oh yeah, I will quickly cover what we're doing for the next 3 weeks. For the next 3 weeks, we'll be doing bivariate data analysis, inferential analysis, some more statistical analysis, but inferential is slightly more complicated. And then we'll start working with Python. I will teach you how to do your data analysis on Python from scratch. So everything that we have done now will be repeated on Python. So you will do everything that you've done here and more, obviously. You'll be doing all these descriptive analysis on Python, all these graphs on Python. It's easier to do graphs on Python, trust me. It's super easy, and we do that. And along with that, we'll also go over this entire list of things you need to learn. So we've done the skewness and normality. We haven't done the correlation scatter plot. That's for the bivariate data. We've done the bar plot. And the line plot is just same as bar, but rather than doing bars, you just do lines. We've done the box plots. I will tell you about outlier identification. I only done one example, which is the outliers using the interquartile range. But there is more that we can do. I'll go with that one as well. And then we'll go into inferential statistics, which is with distributions, confidence levels, hypothesis testing, and everything. Again, if you guys have no clue what these are, I will take it at the same pace we are going right now and explain everything to you. That's basically the end of this training session. Now let's do some examples. Okay, before I start any examples, are there any questions with this analysis, with this lecture, guys? If you have any questions, you can ask me now, and then I'll try and answer it to the best I can.
I have a question.
Yes, Ayodeji.
Yeah, please, as a student, sometimes we need what you call like an handbook, right? So funny enough, we don't have an handbook, okay, like maybe a presentation or a PDF file. And yeah, it's not all day because I think last week lecture, because sometimes I just download the video and listen over again. All right, but last week lectures we couldn't download it or we couldn't find a link to always download and everything. But for me, I would have preferred where I can download the videos and also have a presentation so that I can always, read on my own over and over again. You get it. So I don't know how you can help us with.
Yeah, I understand what you mean. What you want is just a report or a handout to go along with this one. That will definitely be done. The only reason I haven't done it here is I'm gonna try and explain more of you, and then you guys can go through videos and listen to the explanations again to understand it more. Because in every single lecture, I always highlight the importance of asking questions about the data you have and what can you do with it and what does it mean. But if I give you a book saying, oh, mean is just the average of the data you're getting, that's all you know. But you would never think about it saying, what is mean? Why do we take an average of the data? What does it mean? All those things. That's the only reason why I didn't present this or present you with a handout. But once we go through a substantial number, which is basically once after next week, you will get a handbook explaining every single technique and analysis we have done. And then once I start going to these complex ones, you will definitely get a handbook every single time because I won't be able to explain this. Actually, that's not correct. I will be able to explain this, but you won't be able to keep on watching the video to understand explanation again and again. You'll be looking at a handbook for that one. Does that help you, Ayodeji?
Yes, thank you.
Right.
So,
Anyone else have any questions?
yeah, so in the 3 weeks that you'll be away, when we watch the videos and we have questions, how do we reach you, or how are you going to help us with that?
Very good point. Here we go, Discord. So if you have any questions, you can put them in discussion. If I don't answer them immediately, I hope your colleagues can answer them, because I know people here have some data science data science backgrounds or data visualization background that they've done before this course. So I am expecting them to help you out as well. I will do it. I'm not going to say I won't do it. I will definitely do it, but I want them to join in as well. Does that make sense, Bola? So discussions, that's where everything goes. And then if I can't,
It makes sense. I don't know how to put it. If particularly those who know it, we want everybody to participate, would that not even be a function of their availability? Or even for you, your availability, it's when you see that message that you try to answer it. So what if I'm actually going through it at that point in time, and at that very time, I need to understand what I'm going through at that point, and no one is available to chip in, then what happens to me or whoever is concerned?
that's a very good point, Bola. You're trying to say you want continuous access to questions. Even now, when you have questions, you either send me a message on WhatsApp or you send me a message on Discord, and I will get back to you when I have time. And I'm generally relatively quick at replying, so you will get an answer. If you don't get an answer, you will get it slightly delayed. I don't think that's an issue if you get your answer one day delayed. Would it be an issue? So if you're sorry, go on.
Well, I think it will be. I mean, if I'm trying to learn for that day and I get to a point I don't understand, and my question is being definitely, I will not get that point at that time.
Yep.
So I will either leave whatever it is I'm reading and wait one day. I think one day after is a lot. If you tell me, okay, I can do 3 hours after Bola, that makes sense. But one day, honestly, is a lot.
One day is a maximum. It's not the minimum. Sometimes you can get a response with another within 20 minutes.
Well, I hope it works. That's just it. I hope so. If not, maybe we'll have to change stuff.
Yeah. It's the same even now, right? If you have a question right now, you can only ask during the sessions. You can't ask away from the sessions, or you can get a response immediately away from the sessions. So let's say you're working on this and you have a question on Sunday. Are you going to get an instant response on Sunday?
But if you were in class teaching me, I'll ask and I'll get an instant response. You understand what I mean?
Okay.
Which will help me to understand it at that point in time.
Okay, so you're saying
I don't know. I don't know. Let's try it and let's see how it works out.
okay then, yeah. But I have to go to India because of an emergency, and I can't say no to that. And I'm sure it's the same with most of you as well. If you have a family emergency, you'll
No,
always.
that's fine. We understand.
So any other questions, guys, before we start doing anything?
Yeah, Vijay, I have a question.
Yes, Amos.
Okay, you are saying that very soon we'll move to Python.
Yep.
Are you saying that we are through with Excel?
No, we're not.
Because I know you didn't talk about pivot tables and creating dashboard with Excel. I've not seen that. Is that the better way to present our visualization? Or there should be a better way to do it?
So pivot tables is something that I will cover through as well. It's not as difficult as as people make it sound. It's super simple. It's just different way of visualizing it. And dashboard creation with Excel is based on data visualization. I'm not doing data visualization. I'm giving you data analysis background, saying what kind of analysis you're doing. Data visualization will be covered by Ola. He'll be doing the Power BI and Tableau. That's what he'll be doing.
Okay.
It will be covered by Ola. He will be the one that will give you data visualization and dashboard creations.
Okay.
Yeah. So if we go the coaching, no, training, mnt.co.uk, we can go to data analysis. Where is this? Data visualization. There you go. That's in Excel, Tableau, and Power BI. Creating dashboards and storing data. That will be done by Ola. What I'm doing right now is statistical foundation for data analysis. And then, yeah, pivot table is something that I'll cover. It's just a different way of visualizing things. Does that answer your questions?
Yes, it does.
Any other questions, guys? Well, if there are no questions, then we can. Oh, is that a question, Bola? I think that's a no. All right.
No.
If there are no questions, so let's go with this one. So as I said, I'll be adding more datasets here. I get a feeling that Google Sheets is not the best way to store the data. So I'll try and once I get on Discord, once I understand how tasks work properly, I'll try and put all the data here and you can start working on this as well. So Discord will be our main point of contact. So while we're here, let's do some analysis. Who knows what EDA means? Go on, guys. What does EDA mean?
Exploratory data analysis.
Yes, that's the definition or the full form of it. But what does it actually mean? What do you do in it?
I think it talks about the descriptive statistics, basically.
Exploratory, that's correct, yeah. So you look at every single thing and you try and understand what's going on. So let's do the first thing. So what happened here is a Good Fitness, being a company, collected data on the 3 products they have, namely TM195, TM498, and TM798. So they are TM195, TM 498, and TM798. Those are the 3 machines they sell, and they're trying to understand what's happening. I'm trying to understand the user base for the 3 machines the company sells. I can't spell sales for some reason. So the first things first, let's try and understand about the company's target or the user base. Let's look at the average age of the people that are there. The first thing you want to do is user base exploration. So let's look at the average age of the user. How do we go about doing the average age of the user, guys? Is that a answers from someone?
Mean?
Is equal to average
Yeah, mean or average is correct.
That's average equals average. Then you select the range.
Very good. You can select the entire B range. So the average age is 28.7 years old. All right. Let's now, what else can we say about this? What's the next thing we look at? We know the central tendency. And then what's the other one we look at? Dispersion. How do you look at a dispersion? Variance. Variance is a good idea, but instead of using variance, we always try and use standard deviation. And let me tell you why we need to do it that way. So if I open this lecture 2, I should probably have these at hand. So yeah, the reason being variance just not showing clearly. So the variance is the squared value of this. So if you're looking at the age and you look at the variance, the unit for the variance will be squared. So it'll be years squared. Does that make sense? You're saying, oh, the variance is 22 years squared. It does not make sense. So you always try and use standard deviation, which is the square root, and the value has the same unit, or FLF does, okay. It has the same unit as the data you're measuring or you're understanding. Okay, that's the, she's coming back. Does that make sense, Ayadeji? I think you're the variance.
Yes, yes, standard deviation.
Standard deviation. You always try and use standard deviation because they're the same units. So you do standard deviation by ST dev of this entire range. And then again, you can get rid of this entire thing by doing that. And you find out it's 7 years standard deviation. So the actual range or the majority of the population is between what? Men.
Oh, yeah.
FA, is that a question or is that just background noise? I'm going to assume it's background noise and I'll just mute you for now. So yeah, what we do is we get the minute or the standard deviation plus how do I do this? Mean minus standard deviation, which will be this minus this. Why can't I do that? What? Because I did that with 13. There we go. And then mean plus standard dev, which will be that plus this. Why did I do this range? The reason I did this range is to say 66% of the population are between 21 years old and 35 years old. All right, before I do any of these, let me just say this. I'll write a description. The average age of the user base is 29 years old, with a standard deviation of 7 years. This means the majority of the users are between the ages 22 and 36 years. Does everyone agree with this statement?
Yes, I think this calculation even makes me to understand that deviation more now.
Yep. I'm glad you understand this, but before we do this, what did I say about standard deviation? It should only be used for normal data. So let's quickly check if this entire thing is a normal data or not. That's an important thing. So sorry, it's a trick question because you have to try and understand whether it's a normal data or not. So which one are we selecting? We're selecting histogram, where is histogram? Histogram. And you're not looking at gender, but you're looking at age. It's not like, Ooh. You're only looking at B, you're not looking at C. There we go. And then if you go to customize, we can go to horizontal axis. Where is this? Histogram. There you go. Change the bucket size to 2 years. What's going on here? It's not counting genders. Sorry, let's restart this. Something went wrong for me. So you select the entire age. You go to insert, chart. Again, guys, this is the first time I'm looking at this as well, so we're both learning this together. I purposefully didn't look at this data because I want to find out if the data analysis we're doing is correct or not. Because I don't want to be standing here or sitting here and saying, this is what you should do. I want you to sit down together and understand it. So what we do is we start changing the data and we look at this. So if you look at this, what can we see? It has a positive skew and it's averaging between 25 to 30 years old. Let's try and increase it a bit more, 10. Again, it's somewhat normalized. It's not exactly normalized, but it's somewhat normalized. So we can try and use standard deviation to understand it. That's just proof that we can use it. Okay, let me give an example. When should you not use it? If you see any data that's like 1 year old, two, anything that starts off with big and then keeps on going down. So if you don't see any of this from 25 to 15 data at all, and you see it, you know it's just an asymmetrical data, and you shouldn't use standard deviation there. But for this one, you can see somewhat of a standard deviation here, with all of these being an outlier. So anyone over the age of 41 being an outlier, so you can use it. So let's write this down. A user base age distribution. So that's the frequency. And then let's go with the vertical axis, and then is there a, oh no, it should be the horizontal axis, and is there a label? Of course, it doesn't have any label for me set up. And then we say no. I don't know how to add the title there. Anyway, x-axis isn't the age distribution. All right, that's good. That's the first thing done. We know the entire age and we know the distribution and the range. Now let's look at the same thing again, but what's the other thing we want to look at? We can look at, I want you guys to come up with an idea. Which one should we look at? We've done the age. Should we look at the education or the income? Which one do you think is the right one to look at?
Income.
Income, let's see. Let's look at the income over here. What's the average income? So we do the same thing again. Average income of the user. So I do, and then that will be, so rather than using B, what we'll be using is H. We do the same thing here again. H. And then yeah, the average income of the user is 53,000. I don't know. I'm assuming this is pounds. And then the range of them is 37 to 70. So that means they're slightly upper middle class. You can say that based on the distribution and based on the average. Based on the average and the distribution of the user basis income, we can assume they are upper middle class. Again, this is me just randomly saying it because I'm assuming anyone with the salary of 40 grand are generally in the middle class range. I might be wrong. But yeah, these are kind of explanations that you can come up with. Let's do the same one with not income, but let's do with education. By the way, the education over here is measured in years. How many years have they been in education? So if you're going through your primary school and secondary school, that's 11 years of education. If you finish your A levels, that's 13 years of education. Again, it depends on area to area. If you're in America, it'll be slightly longer. If you're in some other countries, it might be smart. Actually, I don't think any other countries has a smaller education rate or education years than UK. But yeah. Education years of the user. Oop, let's just change that to D. And these are not that, these are just numbers. So on average, they have 15 or 16 years of education with a standard deviation of 2 years. Is that really useful to us? maybe. So that's the first thing we've done with the user-based exploration. But now let's try and break this down. Let's try and create something called a pivot table. So, and Emma's asked me this, are we doing a pivot table or not? But pivot table is basically breaking them down into different components. So over here, we have three nominal categories, which is TM195, okay, TM498 and TM798. Those are three machines. So let's try and do the same thing we did over here, but for each and every single individual one. So we do insert, pivot table. Let's do on a new sheet. And then, which is basically this entire thing. Let's select the data range and press OK. And then new sheet. Did I select it correctly? Yeah, I did. So yeah, our rows, no, our columns will be the product. So we just go and drag it to the columns. And then our rows can be the age. Maybe not the age. Let's do this the other way around. So the rows will be product and the columns will be age. Nope, that doesn't help either. Values will be the age. Yeah, there we go. And the gender will be the columns. So we're breaking everything down by product and the gender. So what it does is it does things automatically for us. It takes the average or it calculates the total user base. So for TM195, there are 1,138 females. It's not some, it's count. Yeah, there are 40 females that are using the TM195 and 40 males using it. There are 29 females using TM498 and 31 males. And then there are 7 females using TM1798 and there are 33 males using it. So we know the total user base there. Now let's get rid of that and let's change something else. Let's look at the income the same way. Instead of sum, we can take the average of it. And then let's select all of them and then make them into values. This is quite an important thing or interesting thing to look at. Let me see if we can zoom in over here. We don't care about the total, but so yeah, we can look at the total over here. So if you look at this, what's very clear that you can see? Can anyone tell me that? What's jumping out? You can see that TM798 has a higher value or higher income than everyone else on average. So what does that mean? That TM798 is an expensive product and that only affluent or rich high income members buy it. And then TM195 and 498 are the median values, and then people that are in the middle income select it or buy it. Do you think that makes sense, guys? Let's do the same thing.
Yes.
Yep, let's go to the income and let's look at the mouse. With the mouse, we're not doing the sum again, but let's change that to number. And then we take that average again. The same thing is the people with the highest level of product, they have the highest usage of it, so they go far longer on it than the rest. So yeah, these are the kind of things you can do with pivot tables. You're trying to look, so the way we look at this is, if we go back here, I don't know, when we looked at the previous example, when I'll go back to lecture 2 example, when we looked at this example data, I didn't do that here, did I? God damn. So what I should have done is I thought I broke down each and every single thing into individual components and do it. So I'm just doing like equals average if this criteria range saying this entire thing equals this. We're taking an average of the entire income. So rather than doing it that way, we can use these pivot tables to do our work quickly. That's basically what I want to try and show you there. Lecture 3 examples. There we go. We're going to pivot tables with them. So let's look at something else now. Just made notes on them. Let's look at the. Where is the range? It doesn't have the range here. Sorry, it doesn't have the range here, but let's look at the range on our own. So let's write down TM 195, TM. As you can see, I'm quite rusty with using Google Sheets. If it's Python, this would be so much simpler for me. Anyway, that's not an excuse, so ignore I said that. So let's look at the minimum mouse, maximum mouse, and range. So we do equals min ifs. That doesn't work. Equals min for this entire thing equals this for the range. Oh no, that's not the correct way of doing it. So it says minifs range, we're looking at the mouse. We're looking at the criterion range, which is this entire thing. And then we're looking at the criterion, which would be TM195. So you get the minimum value for that one. And you can do the same thing over here. Max if the range for the mouse, the criterion range being this entire product, and then this. And then how do you find the range? If you guys remember, it's maximum minus minimum. And then yeah, you have to do the same thing for every one of them now. There's an easy way of doing it. Just copy that, paste that. There we go. Copy that, paste that. Just check if you're doing it correctly or not. They're all good. And then the same thing over here. The same thing over here. What can you see? The range for the TM798 is highest out of every single thing there. Meaning the user base for the high-end product, the range for TM798 is the highest out of all the products. This means the user base either uses it very little or uses it extremely high. Uses it very little or uses it extremely well. However, they are the most used ones in both the minimum and the maximum category. Does explanations make sense? Because I feel like I'm just talking to myself while I'm doing this. If whatever I'm doing makes no sense, please let me know. What we're doing is just exploration analysis, trying to see what the data tells us. And then we can do the same thing for, let's do this one, fitness levels. All right, what is the fitness level? Fitness level is basically them saying on a scale of 1 to 5, how fit they are. Let's look at the unique values. Unique of this entire thing is fitness 3, 2, 1, 4, 5. So it's 1, 2. All right, let's leave it at that. We can do the same thing. We can look at the average if the criterion range for this entire fitness. Oh, criterion range, is that what it says? Sorry, guys. Average if for the criterion range, which is this entire fitness, and you're selecting the criteria 3, and you're taking the average of the entire mouse. And then it's the same thing. Can you guys see any? Let's just copy and paste it there. And then let's just paste values only so I can sort it by min to max. That doesn't let me do that. Okay. Fitness level. So people that say that the lowest fitness, they've used their average mouse is very low, and the people with the highest fitness, their average mouse is pretty high. It makes sense. Let's see if the same thing applies to, let's say, the usage. Oh no, let's look at the comparison between usage and the income. Again, as I said, we are just looking at this exploratory data. Unique for usage. That equals average for criterion range. You select that for this, and you look at the income. Income, yeah. Let's not do income. Let's do something else. Let's do same. Most. And if we drag this down. Before I do this, what do you guys expect to see? If the usage is high, you expect them to use it longer or get higher miles. If the usage is low, you expect them to get lower values, right? Let's look at that. Just compare, just make sure it's correct or not. By the way, before you ask, the reason I'm copying and pasting it here is I can't sort these values, but I can sort these values over here. That's why. Usage. We can do sort A to Z. And then we go there and then we choose that. So yeah, we can see it. As the usage increases, the average mouse they have increases as well. And the fitness level increases, the average mouse, yep. So as users predicted, users, yes, the fitness levels, the average miles traveled by them confirms the higher the fitness level, the further higher the fitness level, the further they traveled. And the same way over, here. The higher the usage level, the further the user traveled. All right. Does everything over here make sense? Again, it's very simple. What we're doing is we're using the same analysis we did last time, or we learned from last time, over here to try and understand this. Do you have any questions, guys, about this? While this is happening, I'll just quickly search something else as well. If you have any questions, please ask. I will take silence as this being super easy.
It's not like it's super easy, but You're going quite fast, and like I'm just trying to process everything and take everything in.
I see.
So I believe that by the time we go through it again, then yes, well, I should be fine by the time I'm going through it again and get my hands on some other data.
Yep. All this data will be available right after the call. Right. So while you guys were thinking of the question, I found out how to use the standard deviation formula, which is pretty cool. Let me just search that again. So apparently you have to use the array formula, which is to chain formulas. So you're doing array formula of standard deviation if, oops, ifs, that's not correct. Once again. Yeah, that's correct, yeah. If, what is it, what we're doing here? Yep, we're doing fitness level, yep. If fitness level equals this value, then we bring the moles out. If you do that, there you go. You get the standard deviations. So I know what I did over here is slightly confusing for some people. So I'm just going to write this down equation, the formula down on the beside of it. So what we did was we did array formula and we did standard deviation inside an if condition. We're saying if G, which is the fitness level, equals to N47, this value, that's when we take the values from the range II. So that's how you do standard deviation for a given thing. So if we scroll back here, we've done this min max range for this one. For the mouse, we can do the same with the standard deviation. So we can do mean mouse per machine and then standard deviation per machine. Standard deviation in mouse using the same formulas equals average if the criterion range being A equals this. We take an average of the entire mouse traveled. And then yeah, do the same thing for all of them there. And then over here we can do let me see if this works. Standard deviation if this equals TM195, then you bring out this entire mouse and you do it. Ah, what do you know? It works as well. This works as well. Apparently it doesn't work. Oh, no, yeah. Okay, I'm just going to quickly debug why this is not working. I can try and use the same formula we used over here. Just array formula and try that on there. Array formula, which will be standard def if A equals this. Let me try and get a data fine. Yeah. There you go. So we have to use the array formula at the beginning. If you don't use it, it doesn't work. Okay, 41. So does this follow the same as what we've seen above? What did we say? The range of TM798 is the highest out of all the products because this means the user base uses very little or extremely well. However, they're the most used in both minimum category colors. Extremely well between each other, with each other in the same group. Yeah. And then over here, it shows the same thing. The mean miles is the highest for T795, and the standard deviation is very high as well. The mean and standard deviation values confirms the findings in the range calculation conducted. All right. I feel like I've been talking to myself and doing this very slowly in my own pace and doing this. Next time I do this, I'll probably look at the data and then try and come up with some questions. So rather than doing this blindly, it will make more sense as to why we're doing this and how we're doing this. All right. Does anyone have any questions regarding these? If not, the homework will be to try. Go on. That's a question.
Can you please explain more better about the array formula? I think I'm interested in it. I don't know why you're using the array formula and what are the functions you're doing.
So let's read what, rather than me explaining, let's read what it says by array formula right there. So if you click on this 3 lines, if you click on this arrow key, it says, enables the display of values returned from an array formula into multiple rows or columns using non.
Your image is covering this. Can you shift the stuff?
Sorry?
Your image on Zoom is covering. Can you shift it to the left side of the screen?
Left side of the screen. Oh, I'll change my face, so it makes sense. 1 sec. So let's do that. Equals array formula. Arrange mathematical expression using one cell range of multiple ranges of the same size of function of returns. That means nothing there. That means nothing there as well. Oh, so array formula is basically the same way of doing unique functions. So if you're doing equals unique of a row, which is what I've done here, what it does is it plots all of the data into these 6, or not 6, these 7 rows, because it unpacks the array formula. And it's the same thing over here. The array formula, what it does is it unpacks them. And why does it work with the standard deviation? It's something to do with Google Sheets and how it works behind it. But as you can see, if you use the standard dev with if function, it still works, but it's just not very consistent. Let's see, what does it say? Yeah, sorry, that was not a very clear answer to you, Ayodeji. Ayodeji, right? Yes. I will try and come up with a clear explanation as to why this is and send it to you on Discord. Yep.
So can I use the array or unique on Excel? Can I find that?
On Excel, I don't think it has a unique value on Excel. No, there is a unique function in Excel which you can use. And it will return it as an array. It will just fill the rows below it. All right. Just looking at this makes sense. So Ayodeji, if you use the if function, you will get false because it only looks at the first row of this entire FF value. That doesn't make sense, right? Because if function, you're looking at the entire row and you're trying to get an entire row of values out. But it's not doing that. It just looks at the first value and it does it. So this is, but if you use an array formula, and then put a bracket around this, and you press enter, why does it say ref? Doesn't make sense. So again, you need 54 rows for it to make sense. So if you just drag this and no, that doesn't make sense. Please insert more rows. It says that you need 54 rows for it to work out. But what you can do is you can do count of this entire thing, and it counts how many there are. It's like an array of saying 1, 2, 3, 4, 5, and you're just counting, you're working with the data for all of them. Does that make sense to you, Ayodeji? Or is it still confusing?
Yeah, exactly. You can confuse a bit, but I'm going to read about it. I think I found unique on Excel.
Mhm.
Yeah, but I think I'm going to research about it.
Yeah. So let's go over this again. If you're doing the value for if, how does it work? So if you're saying 2, 3, 4, 5, and this is 2, you're doing if this value equals 2, you return yes, or you return no. And then let's do the same thing over here, copy and paste it down, and we copy and paste it down. You should, this will be no, because you're comparing 3 to 2, they're not the same. That's why it's a false and you get no. But if you're doing the same formula, but instead of doing just N62, you're doing from N62 to N68, 68, 65. And you're comparing to 2, how would that work? We have to get 5 rows saying yes, or 4 rows of saying yes, no, 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 right? Is that what I did there? Let's do that. He's saying the first value. I'm thinking he's only comparing the first value. So let's change it to 3, 2, 1, and 2. He's saying no, because it's only comparing the first value. That's what the if function is doing, even if you're doing an array value. But if you do array formula and you do sum, so with this if, there are 2 values that says yes, because there are 2 2's. And if you're adding them both, the answer should be 1. Why is this not working? That should be 0, 1, and 0. It gives you 2. Does it explain it? It converts array functions into a singular value. It just combines them all.
Okay, I am. Okay.
It seems like you're still confused. I will try and do a write-up for this, and I will put it on Discord for everyone and yourself to see. Let me make a note of that for myself. So, yeah. Explain how array function works for Digi. Yeah, that's good. Anyway, I hope that should be the end of the class. I hope it makes sense to you guys what I try to explain. What you need to remember is basically we finish the descriptive analysis, go over the lectures, or the presentations, so you can remember these things. I'm just getting the graphs up so you can see what exactly I'm trying to. So you know how all the descriptive statistics work and what they mean, the properties of data, what they are, and the 3 graphs I introduced here: the bar charts, pie charts, and frequency tables and distributions. Okay, if there are any questions, please ask me on Discord and I will be explaining them as soon as I can. And in the same way, if I'm going too slow or too quick or just going very confusing, which is basically, rather than doing this exercise blind, if you want me to prepare in advance for the exercise and do it, please let me know in the feedback. And I will try and do that for the next session, foreseeable ones. So I don't know if you guys preferred this me doing it this way, which is just basically going along with you and then looking at this from an open mind, saying what kind of analysis we should do. Do you guys prefer this, or do you want me to do it differently?
Well, like I said, everything seems so like a lot to take in. Like, to me, you are still performing magic really right now.
I see.
Until maybe go over the slide again, I go over it again, then I can. But even at that, your delivery tonight is quite fast, very fast. But that's fine. Maybe going through the lecture would make me understand. But actually, this mode of lecture actually is not preferable to me.
It's
My
not
opinion.
preferable. How would you prefer it then?
I think which lecture was that? Second lecture, third lecture? I think second and third lecture, I'm not sure. You actually broke everything down. And funny enough, the assignment that Ola gave us, you can see that he didn't even teach us jack. But what I actually used to solve that assignment was what you taught us. I actually went through that class and I was able to use what you did there to actually attempt all the questions, which was a very good thing. And I was quite happy about myself that, I was able to use what you did in class, which Ola didn't teach us, to attempt his question. And to a large extent, I was able to do something. So for me, I think I would prefer that, knowing that I'm coming from a zero background. It helps me. When I go back, I can understand and relate and practice it and get it. This is my own opinion of how it affects me and how I want it to be.
Okay, so what you prefer is when, rather than going through this entire thing blind and showing you how I think as a data analyst, you want me to prepare everything in advance and just tell you this needs to be done A, B, C. And then I will leave you to do your own analysis in the future, being like, where can I use it? Where can I not use it? Is that what you prefer?
I'm not saying that's what I prefer. I'm saying that in terms of making me understand, like right now, I just made a point that right now you are very fast with today's lecture. But I preferred your second and third lecture because you actually broke everything down. And because you broke it down, I was able to use that information to attempt a very tough question, a seemingly tough question that I hadn't handled before, is what I'm saying. So I now don't know how you want to interpret what I just said. I don't know.
But if you want me to break it down and go through it slowly, that means basically just prepare the question and answers in advance rather than going through with you. Sure, I can do that. And if
my opinion, though, let's hear from other people. My opinion.
That's fine. Can you leave this in the feedback then? So that way it's written there and everyone can read it and look into it.
Okay.
I was gonna say something.
Go on.
Basically, it's not that you went through the lecture quite good, but the thing is, I think the pace at which you were moving for someone that is just coming from a zero background will have to struggle a bit to pick, especially when you were like comparing, like male to female or, using those formulas. I think that's what she's trying to say. Because myself, I'm also struggling to pick it up. You can see that all through the lectures, I've not been able to say something because I've just zeroed my mind to say that after this class, I'll have to go through the video again. Probably then I'll be able to pick it to understand what it is. Yeah, I think the pace at which you were moving today, it's a bit faster than previous lectures we've been receiving from you. Yeah.
Okay, I can slow down. I
Yeah.
can slow down even more.
But every other thing is fine, but just that pace, for someone, you're dealing with formulas. You're trying to teach us the if, the that, and all of that. So it's something we're not really used to before. So it might take a bit of time for us to actually assimilate that. So, but that's fine.
Okay, so correct me if I'm wrong, but when you're saying that, if I go to lecture 2 example here, please bear with me. No, not that one. So when I'm doing this, because I'm writing all my equations down or formulas down, it made more sense to you? Is that what you're trying to say? Something like this?
Yes.
Okay, I will keep that in mind. So I'll make the formulas very clear and vocal so you guys can follow it quite easily.
Thank you.
Thank you very much. Again, if it's not too much trouble, can you please put this in the feedback channel? Because I don't know if you guys noticed this or not, but I'm quite new to, what's the word? It's not new. Yeah, it's I recently started working with Amintip IT to teach data analysis. Before this, I used to teach maths A level and university engineering. And then because they're very used to maths, it's quite easy for me to just jump ahead and go through it really quickly. So if that's what you're worried about, me not going through very quickly without giving you all the correct explanations, I can slow down even more and then make sure it's very visible. As I said, I thrive on feedback. So if you tell me to go slow, if you tell me to show all the formulas I'm using, if you tell me to explain the formulas, I will do all of them. So yeah. Thank you very much, guys. And
Thank
then
you.
yeah, just make sure you put them on Discord so I know I can just follow it. Here you go, feedback right here. All right. With that, I will say that's a successful end to the lecture 3. And then look forward to the next recordings that will be uploaded down the line. Okay. See you guys. Have a good night.
Night.
Bye.
Bye.